Welcome back everyone to the Hello World Sky. This is another episode of the C++ Raycaster game series, and in this video we are going to continue by starting to cast multiple rays in our game. So I'm going to open up my terminal here and I'm going to move to our directory where we had our project, and I'm going to open up the renderer.cpp file. And if you remember, in the last video we kind of finished up the whole algorithm for drawing the actual rays. And if I actually just go here and run make, you can see that we cast a single ray here and it hits the walls and it stops when it hits the wall. So that's working, and that's working quite well. So now we can continue by actually implementing the rest of this. So the remaining part, which is casting multiple rays. Now in order to cast multiple rays, we'll need to refactor our code a bit. So I'm going to go up here and I'm going to create a struct here, which we are just going to call ray, like that, and it's going to contain an sf colon vector 2f, which we can call let's call it hit position, and we are also going to have a float here called distance. So yeah, this is going to be our ray struct, and we are going to create a function here which will return a ray called cast ray, and it will take 2 points, an sf colon vector 2f called vector 2f. We can just call it let's call it, for example, we can call this our start position. We just call it start, and a float called angle in degrees, because this is going to be the one in degrees. We'll convert it into radians later on. So we are going to copy this from here, not paste. We are going to copy this from here, and we are going to go down here and let's just paste that, and we'll now actually put the implementation of this here like that. And inside of this we are gonna go up here and basically copy this whole thing that we have got. So I'm going to copy the whole algorithm for drawing the ray. Yeah, up till now not the actual drawing part, but till here we are gonna draw this, and then we'll go down here and paste that. Paste that, and that's not correct. Yeah, now that should work. So we're gonna paste this here, and of course there are a lot of problems here. One thing that I forgot is that we need to let's remove this, and we are gonna have to add another float here called cell size that we'll actually need to take as an argument. Afterwards, it's giving us problem about player.angle. We are gonna change this variable to the angle in degrees, like that, and now it's giving some 20 or so errors here about different things. Well, of course, the obvious problem is that we don't actually have the map right now. So instead of taking the cell slide, let's actually take the map. So we are going to create a const map and map here, and these three are the only variables that we'll need for casting the rays. Of course, we'll need the map because, well, without the map we can't really do anything. So we can say angle in degrees, and in here it's working, and it's still giving us some 20 or so errors, but we'll fix those in a second. Let's go up here first of all, and we are defining this. We are going to have a const map and call map, and let's actually go here and make this function static, which means it will have internal linkage. We don't want to have this function available externally, so this will have internal linkage. And now it's giving some errors, and first let's go ahead and actually use this function. So we are going to call the cast ray function with our player dot position, yeah, and for the angle we'll just say player dot angle, and for the map we can just say our map, and we'll cast the ray and we'll store the result in a, we'll just call it ray is equal to this. And after we have cast the ray, of course there is another variable we'll need to add here called hit, which will represent whether we hit anything or not, because if we don't hit anything, we don't want to actually do anything, because even though in our map we'll always hit something, but we might not hit something in some cases. So in here we'll just go here, and for the second one we'll pass in our ray dot hit position, and we'll only do this. So if not ray dot hit, well, we can say if ray dot hit, then we are going to go ahead and do all of this. So let's go here, cut that, go up here and paste this here. So this works now, and we have still got some 20 errors because of all of the undefined reference to player here. So we need to change all of these these references to player.position and replace them with references to start variable. So as you can see guys, I've gone ahead and changed my cast ray function here, and now we are using start.x and start.y everywhere. We are not using player, and now we are getting no errors, but we are getting one warning, which is that we are not returning anything. So for this we can just say return, and we can call this ray, and we are you can see we have got like in the ray, if I open up the ray struct, you can see we have got a vector to in position, a distance, and a bool hit. So in order to do that, let's go there here, and let's create two bools here. So let's go up there, up here we are doing all of this. So we are creating like a bunch of things here. Let's also create two booleans. So we'll create a bool v hit, and we'll set that to false, and we'll create a h hit and set that to false as well, because well, by default we have not hit anything. Now if we actually hit something, then along with calculating the distance, we'll also set v hit to be true inside of here. And remember that if we hit any one of the walls, then our hit is true. So we are going to go here, and let's just say h hit is equal to true as well. So this is going to set that correctly, and when we are returning our array for the actual position, we'll return we'll check if our h distance is less than the v distance, so vertical distance. If that's the case, then we are going to return our h ray position, or else we are going to return our v ray position. And for the distance, we are just going to return std colon min, and we are going to take h dist and y dist, and we are basically gonna get the minimum of those. And for the final value, whether we are have hit anything or not, we are going to set h hit or v hit. So basically, if either one of these is true, then we are going to say that yes, we hit or hit the correct place. So this is gonna do that here for us. And actually, speaking of that, we don't actually need these two variables now that I come to think of it. We can just use a single hit variable, which will set to true if we hit any of these, and we are not setting it to false anywhere. So that means that this is bound to work correctly. So we can just use a single hit variable here, and that would save us a lot of trouble basically. So we can just say hit here like that, and yeah, that works, and it's now not giving us any warnings at all. And in here we are using this correctly, so let's go here and run that, and hopefully this will work. So you can see it's still working like it did before. We are still casting the array correctly, except now that we are now doing it in a separate function. So but we can see that it is essentially working, and it's working correctly. So now what we can do is go up here in the draw ray function, and in here currently we are drawing like only one ray. So we can draw multiple rays. We can basically put this in a for loop. So we can say for let's say size underscore t I is equal to 0. Let's say for example I is less than 60, and we're going to say I plus plus, like that. And let's go ahead and do this. Now what we'll need to do is we'll need to cast a ray for like every angle of the player's field of view. The higher number of rays we cast, the better we'll get, the better quality we'll get. But for example, I'm going to just create a constant expression float here called player FOV, which we'll set to, for example, 60 degrees. And for now, we can just cast one ray per angle. So we'll say we'll actually create a float here called, we'll not use size underscore t, we'll just create a float angle, and we'll set that to player dot angle minus our player FOV divided by 2, so that it starts from the left. So we are going to go until our angle is less than our player underscore FOV, and we are going to basically say angle plus equal 1, for example. Yeah, like that. And when we are casting the ray, we are going to use this angle here and not player dot angle. So let's go ahead and run that. And well, now you can see that we are actually casting somewhat of a cone here. However, it's not exactly working correctly. When we look left, it's kind of breaks, it seems. The reason for that is that it's going until the angle is less than player dot FOV, but we'll need to say is less than player dot angle plus player FOV. So we'll need to do that. And now if I run this, you can see that we are essentially casting a whole like light beam or something, and it's showing us basically what the player is currently viewing. So this is like a bunch of rays that we are casting. We are casting one ray per each angle in our FOV, and currently it's not very like dense, but if I go ahead and want to make it more dense, I can do it in a really easy way by changing this step to be lower, for example at 0.5, and changing this to be increasing it by 0.5, and yeah, that's pretty much it. We can increase it by 0.5, so we can lower the step to kind of make it more dense, and now you can see that we are still casting in the same angle, but the number of rays is greater. So this would mean that the quality that we draw with would actually be better. But apart from that, you can see that it does seem to be kind of doing what we want it to do. So it's doing exactly what we want it to do in a correct way, and our player is basically having this view cone around the actual player. So yeah guys, this is pretty much it for this video. I'll see you in the next one, in which we'll go ahead and try to start implementing our like transforming this 2D race that we are doing into like our 3D world. So I'll see you in the next video. Make sure to like and subscribe so you don't miss the next one. Make sure to share this video with other people as well, and